And welcome everybody to the Daily Space Weather. Welcome to space. I'm your host Dan, aka smAsho. And while we're looking at the sun here, 48 hours worth of its activity in this 304 angstroms view, we see more ejecta headed in the Earth-facing vicinity. We'll talk all about it. Another prime example of how we don't need to see sunspots or even solar flares for large plasma filaments to be ejected, and you can see all kinds of plasma filaments right now up here around the North Pole region. So there's lots of stuff going on here despite zero sunspots. In fact, more stuff than we're able to even cover. And this is just an ongoing situation as ejecta keeps getting sent Earth's way. So we can even see some of this filamentary behavior here in the 171 angstroms view. And this is the same 48-hour video, just in ionized iron wavelengths instead of ionized helium wavelengths. And so lots of stuff going on here, and tons of things to cover. By the way, if you enjoy the content, please press like and subscribe on YouTube. We've got links to other areas on the home title page, and thanks to all our new viewers. Now here is an image of the magnetogram, and you can see there's nothing even resembling a sunspot, although we do have some active regions rising over in this area. Still no sunspots showing up, and you can make these videos yourself at the Soho Observatory. It's the Soho movie theater, and that's the magnetogram. So here is the view from the LASCO C2, another part of the Soho suite. Now this coronagraph is right between the Earth and the Sun, and we can see another halo ejection here. As you can see, ejecta on both sides, mainly on this side, but also over here. So another indication that we have more primarily hydrogen nuclei headed toward the Earth. So we just saw a little strike from one coming in yesterday, it looked like, on the solar wind. And we'll get to more data in a minute. Here's the view from the C3, basically a zoomed out view of the same thing. A different image on the coronagraph. And you can see most of that ejecta will miss the Earth to the east, out in this direction. But again, there is some ejecta coming out to the west also. So another expectation of a little bit of a bump up in the solar wind there from that. Now this is the view from stereo A, which is actually located a few months behind the Earth, orbitally speaking. And you can see actually that coronal mass ejection actually was followed by one facing in the opposite to the Earth direction. So you see one out here, following this one headed toward Earth. And Earth is somewhere out in this area. So that's the view from stereo A, and there's all of your coronal mass ejection news once again covered. I don't know how NOAA's missing these, but we're not missing them on the channel. Here's the 171 angstroms view on HelioViewer. Let's get the latest image. And we'll fade that out to magnetogram. And we're going to zoom in on that region there, as there is an active plage rising here. It's a cycle 25 plage, and that is this area. Whoopsie. That's not that area at all. HelioViewer doesn't like our epic pen, apparently. Anyway, it's up here where my pointer is, and there's also a cycle 25 plage down here. Nothing too exciting. Let's take a look at those areas in 171 angstroms. And that's a short HelioViewer movie. I don't know why it didn't put the date stamps it usually does. A little bit of quality problem too. I apologize for the lack of quality there. I don't know why the resolution's so low. And there's where you see a bunch of filamentary activity up there around the North Polar region. And we also have the 304 angstroms view of that same area. And you can see a very large plasma filament right over here. And let's hope that one doesn't end up on our back doorstep. as we're getting a serious amount of ejecta headed out the interplanetary magnetic field toward planet Earth. You can see the three-dimensional nature of that giant plasma filament. KP index did get up to 4 briefly, right around midnight UT, for about 6 hours last night. 10.7 centimeter radio flux, which apparently is responsible for the beaching of gray whales, still quite low at 70 solar flux units. X-ray flux is still looking pretty flatlined, and if you're wondering about those X-ray imagers, there is something going on with them. They've been down since, I believe, the 10th of February. And I looked quite in depth into the GOES X-ray imagers, and I don't see any of them online. And let's talk about the ramping up of Cygnus X3 while we're talking X-rays. My favorite X-ray source, and indeed cosmic ray source, is Cygnus X3. One of the usual suspects for cosmic rays is ramping back. So you can see this level right here around 0.07. That is way up here. So those transients that have come out of it are quite powerful in terms of its overall scale, indicating that it's moving back into its midline range and coming off of its lows. And you can see how cyclical Cygnus X3 is. Cygnus X3 Deneb, the tail of the swan. Next at the Neil Gorel Swift Observatory, we're going to look at Sagittarius A star, the core of the Milky Way galaxy, the massive radio source located there, and it is indeed ramping up also. So there you can see these transients out of Sagittarius A star. I'll leave this up for a minute. Here's this one. This one's at about a level of 5.7. And you can see 5.7 is actually way up here. Some of the highest transients, X-ray bursts that you ever see from Sagittarius A star. So there's your correlation, there's that, and there's the daily. So an uptick in X-ray flux from both Cygnus and Sagittarius A star. And next we'll look at the Crab pulsar. Don't be crabby, understand the pulsar is an extremely consistent X-ray source to the point where it's used to calibrate telescopes. And Crab is looking pretty average here. Although we did see its X-ray flux drop very low, surprisingly low here in 2019. And next we'll take a brief look at massive radio galaxy 3C405. Which is going to be on a t-shirt soon, folks, trust me. And nothing too special really going on there. Some pretty high-level transients out of that, but it's the second strongest radio source in the sky, second only to the sun. So it's a little bit dicey, the data from 3C405. And let's look at one more. We'll just go back to the other side of the galaxy once again, over toward where Crab is located and Gaminga, the Vela pulsar. Check it out. Vela pulsar just had a crazy transient outburst. Wow. Off the scale. Check it out. Those transients are above this scale entirely. They're going all the way up to significant densities here, up all the way to 10.10, and that's like up here. So big time outburst from the Vela pulsar. Somebody get a hold of your radio astronomer and let them know about that one, as that one needs to be studied. The Vela pulsar, super interesting. And once again, we're stumbling onto things we're not expecting to find, folks. So if you didn't hear it someplace else, and I'm sure you didn't, you heard it here. And we always link to the Neil Gorel Swift Observatory. Today we're not covering cosmic rays. We covered it yesterday. If you want to hear about the latest 30 days of all those stations, watch yesterday's video. Real-time solar wind showing a phi angle of 332. We see the BT-BZ converging on the zero line. So fields are looking weak, and there's a whole lot of plasma in between the measurements, and that's why the fields are looking weak, because the fields aren't weak. And we're going to show you some very, very strong fields momentarily on the Gong2 data. First, let's look at the solar wind density. It's quite low at 2.1 protons, and it's been sinking all day, and this is what got it up to a KP of 4. It made it all the way up to 567, and that actually looked like a coronal hole wind stream there, which initially looked like a coronal mass ejection. It kind of arrived oddly with a density and velocity spike. So, solar wind speed now at 457 kilometers per second, and let's refresh. There's the latest data from the ACE. Here's a geospace magnetosphere movie, and we shouldn't see any fireworks on this unless they're purely magnetic in nature. It's probably going to weaken toward the end, and that's 4 hours of data. And we cover this daily, as this data is not accessible yet in the archive as far as I know. Next, ground geospace magnetic perturbations, and we continue to see pulses coming out of the Pacific Ocean, right in this region. And we see two north poles and a creepy south pole creeping toward southwestern Australia. GOES magnetometer still looking very spiky and kind of all over the place, which is no surprise with the amount of plasma the sun has been blasting out. So again, let me remind you folks, we don't need sunspots. We don't need any real features on the sun for it to fling plasma around as it is doing now. Here's how quiet it is. So this is the top view ecliptic plane field plot. We cover this every day. It's 1 hour and 27-minute old data, as this is tied together from magnetometers out here on stereo B and out here on stereo A, and 51 of them here on good old planet Earth to come up with the Gong2 data. And this allows us to predict things that you would otherwise not be able to. And we're going to continue to see spikiness on the GOES magnetometer there as the environment is changing here out in the east. And you can see there's some pulling happening on the field there, some opening up of the fields, although I don't see the North Pole charge sliding in yet. And pretty much the entire current sheet is currently charged by the South Pole, shown in red. Here's the line of sight field plot, which shows you the B field also. That's the one on which you live, most likely, unless you're an alien. Please leave a comment if you're viewing the video from outside the B field, shown here in blue. And it's actually starting to even out a little bit. It looks like the North Pole field may pull through. No forecast there. Keep in mind the magnetic environment can change with absolutely no warning. And time to freak out. You ready to freak out? Whoa, my gosh! So that's what the sun looks like on that same view at times of high activity. Now I knew these dates from memory, 9/15/2012 through 9/20/2012. And so here's what the B field looks like now at solar minimum. And here's what the B field looks like at solar maximum. So you can imagine how that affects things. Yeah, you can see the influence of the solar polar fields and so on there. And let's just show you the top view ecliptic plane field plot from these dates as well. And this is what the top view looks like. So that's it. That's an active sun versus an inactive sun, folks. And electron flux is still at moderate levels. Back to data here, current data. And we're seeing a cratering of the electron flux as protons are using up a lot of the electrons right now. So no very high electron content forecast or anything. Expecting fairly well-functioning GPSs even at the equator. Here's the ionosphere, which is looking fairly normal. save for some charge-ups over the South Pacific at night. It's been going on for months, and it's just a feature of, really, it's probably an after effect of the South Atlantic anomaly, and it's nothing to really worry about. By the way, our video got demonetized, and then it got remonetized after we appealed it, only 2 days after everybody watched it. So if you'd like to go back and watch our older videos, I believe it was another coronal mass ejection, so 3 days of covering coronal mass ejections that NOAA didn't see on the channel. NOAA didn't see it, NASA didn't see it, but we saw it, and it's apparently some sort of a mysterious secret. We've also been streaming live to Twitch, and that's because, for obvious reasons, Twitch's platform is fantastic for live streaming. Did you hear Tom Steyer dropped out of the race? Oh my goodness. Follow us on Instagram. We've even got some of our comments, such as this one on BitChute. Cool, one other thing. I'm a published poet. You have the clap. Get that shit looked at, sap. Pardon my French. Please support us on Patreon. It's patreon.com/smAsho, the real source of funding for these videos, as YouTube tries its best to pay us nothing. We are also on Subscribestar, and that stuff is all linked on the YouTube page. Also check out smashomash.org, smashomash.com/forum. I can think of a website that has more information. Let me play a clip from yesterday's BitChute video. Pearl clutching.
No evidence of a singularity. Survey said.
I do really bad at these Family Feud style questions. Also follow us on other alt tech like Minds.com. The social media that won't shadow ban you or censor you or try to deplatform you or deperson you or do very much of anything to you besides provide the information that you'd like and get you all the views that you want. We're pushing 600,000 views on that site. And here we are at windy.com showing you the pressure maps. We're going to let this advance about 24 hours as we do most days. We're looking at the GFS forecast. We see a shrinking high pressure zone off the coast of California, as well as some odd earthquakes happen. Wait till you see this earthquake that we cover. There's where things will be at noon tomorrow my time, and if you wonder where I'm located, it's in Lehigh Valley, Pennsylvania. Check it out. See that earthquake? It's off the coast of Humboldt Bay. And guess where that earthquake occurred? 500 meters in the air. Oh yeah. You think I'm kidding? I'm not kidding. Look at the look at the depth. The depth of that quake was 500 meters above sea level. So, figure that one out. Figure that one out, tough guy. And we don't see very many quakes. It's pretty calm, although we do see some apparent volcanic quakes going on. Although that one occurring above the ocean apparently was not volcanic in nature. Please drop Mr. MBB333 a line and ask him if there is a UFO up there. Perhaps a mothership. Or maybe it was a gravitational wave cloud. Pardon the sarcasm, viewers. So we see a deep quake at Chile. It's a 104 kilometer deep quake at a 4.4 magnitude. Here's an ultra deep quake at the Bande Sea, 401 kilometers deep at a 4.1 magnitude. Please have a plan if you're in an earthquake prone zone, as we've been seeing quite a lot of deep quakes. There's one shallow in the Aleutian Islands. It's 107 kilometers. So nothing over a 6 magnitude. I don't even think I see a 5 magnitude. It's really an earthquake lull. And guess what always happens at the end of earthquake lulls? Earthquakes. There's another deep one at Chile, as Western South America is still a great candidate for a large quake at the surface. There's one at the Northern Mariana Islands, 149 kilometers. There's a deep one at Afghanistan, 201 kilometers. Here's an ultra shallow one at Hawaii, 300 meters above sea level. How much you want to make a bet it's underneath Mauna Loa? Pardon my squeaky mouse. I'm not sure if I should use white lithium grease or if I should take this thing apart or what the deal is. So it's underneath the flanks of Mauna Loa, not directly underneath the caldera, as so many quakes we've covered on the channel have been. Let's go back to the list. So lots of deep quakes and some ultra-shallow quakes. COVID-19 update. As we have a massive repository about virus on smashomash.com/forum. It's into the 7 pages now. Washington State man becomes the first coronavirus fatality in the U.S. A very unhealthy guy in his 50s who had all kinds of other exacerbating medical conditions. So the first casualty in the U.S., folks. We've also put some solutions up here, some defense mechanisms, and some possible treatment possibilities. Elderberries block the flu virus from attaching to and entering human cells. So shout out to Jess Ewing. Well done. Thanks for sharing that one on Facebook. We've picked it up on smashomash.com/forum. If you're viewing the video, please set yourself up a login. I think we may be over 200 by now. Anyway, elderberries are an antiviral, apparently. Who knew? Apparently Sarah Burrows did, who wrote the article. Also, cold remedies with cayenne pepper and lemon. While those aren't the same kind of cures, they do have effects on your body, which are good. Buy some fresh lemons, perhaps. Fresh lemons, cayenne pepper. While they don't kill viruses, they do cause good things to happen. Also, L-lysine, you can supplement it. You can find it in things like amaranth, alfalfa, wheatgrass, mint, and there are some references also for you, as well as an article from Livestrong, another article from Livestrong, I should say, about what lysine does for your body. It's an essential amino acid that your body doesn't produce itself that's responsible for the production of enzymes, hormones, and antibodies. So as you could imagine, it's super important for immune system function, and it's perfect for people who have crappy diets. If you feel like you're getting sick, perhaps take some supplements. It's pretty cheap. It comes in 500 milligram and 1,000 milligram tablets. Find it at any drugstore, L-lysine, L-Y-S-I-N-E. Here's the current graph of COVID-19 cases. As we push 87,000, and we push 3,000 deaths, and again, one of those. Finally happening in the U.S. as we have 71 confirmed cases as of this moment. As of this moment, we've got volcanoes erupting also, such as Mount Aso, producing a 7,000-foot ash plume, Sakurajima producing a unknown volcanic ash plume, and another one on the list at Papua New Guinea, Bagana, exploding, continuous eruption, producing a 6,000-foot ash plume. Please do not attempt to pole vault Bagana. So that's a new one. I never heard of it. I'm not an expert on volcanoes. Dacono also exploding. Carinci exploding, probably, producing a 14,000-foot ash plume in any case. Popocatépetl exploding, flight level 19,000 there. Fuego, back on the list, volcanic ash observed there. Nevado del Ruiz, volcanic ash detected in satellite. Sangay exploding, 19,000-foot ash plume. Revenador exploding, 19,000-foot ash plume. Sabancaya, puff emissions. Please do not attempt to do a back handspring over Sabancaya down there in Peru. Here's a lightning map, and it looks like there's some lightning strike in the Middle East. And my Arabic is not good enough to pronounce those names. What about you? Value-added service. On this Sunday morning, we're showing you the U.S. Doppler radar at 6:16 a.m. Do you know where your vertical movement in the cloud columns are? Well, that's where they are. Next, we'll look at nullschool.net to look at the jet streams. Here are the eastern jets. Extreme meridional jet stream flow down southwest of Australia, the area where the South Pole just happens to be moving toward. I'm sure it's just a coincidence, folks. Please leave a comment if you think it's caused by CO2. And here's the Western world jet streams. We see a doubled up bent jet stream. Look at the bend over the Pacific Ocean. Check it out. That is extreme. And that is caused by Earth's magnetic fields and its effect on the water vapor and indeed the nitrogen in the atmosphere, folks. Also got an interesting zone right here. That is a serious low pressure zone. And here's your water vapor map for Europe and Africa. I thought that was playing. There we go. There's the animation of that. And you can see that clockwise rotating low pressure system. It's surrounded by dry air, so it doesn't look like it's going to amount to very much, at least not yet. And here is the water vapor map for Oceania. And I did look a little closer at Australia. I see two low pressures there over the center of the country. One of them is an upper level one, and that's the one here. That's an upper level low. And the other one is a lower level low. And perhaps we'll look at doing more significant weather forecasts in the future. Here's the U.S. water vapor map. And we see some warming conditions headed my way here in eastern Pennsylvania. And let's look at these Hall currents over central Texas. And that's actually an upper level low also there. You can see the altitude difference as that moist air is moving over the top of this dry air, which is going to cause a bit of a temperature and pressure inversion, making for dangerous flight conditions. Hey Smash Team, why don't you click the links below the video? Support the channel, Smash Team. Thanks for tuning in. Here's bonus features. Here's the latest intensity gram of the local yellow dwarf, showing us 0 sunspots. Here's the latest colorized magnetogram, and those active regions are not sunspots, and they are actually degrading, I believe. Let's look real close. Not looking like sunspots. If I had to guess, I would say that they're degrading. So no real expectation of those to form into sunspots. I would note the straightness of these field force lines here, looking a little anomalous. And one more bonus feature, it's the 94 angstroms view. And this one's good for looking at solar flares, but it's not good for looking at plasma filaments, because you're not going to be able to see them, but they're going to get ejected anyway. This is 48 hours. We are out of here. Thanks for tuning in. Look for more content coming soon. Probably only to BitChute. It's bitchute.com/smashomash. And don't forget to check out smashomash.com/forum. There's more information there than you could shake a liquid metallic hydrogen model of the sun at. So remember, stare at that thing, don't drink, use the proper instruments, and if you do drink, don't drive it, since it'll never be now again. May that solar wind be at your back.